Hi there, my name is Cole, and today on Investigate, Explore, Discover, we're going to be looking at how vaping disrupts protease balance in the lungs. Now, before we can start talking about what vaping is, we really need to go back a little bit and talk about what smoking is. When I think of smoking, I think about mainly smoking cigarettes, but that's not true for everybody who smokes. There are many different kinds of tobacco products that can be smoked, whether it is cigars, cigarillos, or pipe tobacco. In my not too distant youth, smoking was a lot more prevalent than it is today. In fact, global smoking levels are declining, which is great news. However, 20% of the world's population still smokes, and about 3 times more men smoke than women. Smoking is not without consequence either. Smoking leads to a whole host of diseases all around the body. In particular, it leads to multiple different kinds of lung disease. It can also contribute to lung infections and tuberculosis. And these diseases all culminate in mortality. In fact, smoking is the leading cause of preventable death throughout the world. The World Health Organization says that over 8 million people per year die because of smoking, which is insane to think about. Now, what exactly makes smoking, usually cigarettes, so harmful? When you smoke, you burn tobacco, and who knows how many other chemicals in those cigarettes to produce ash and smoke, which goes into your lungs. In particular, burning tobacco causes the release of nicotine. And nicotine itself is a stimulant which is highly addictive, which gets people on the smoking train of more and more and more. In recent years, there's been a different way of consuming nicotine being brought to the market, and that is in the form of e-cigarettes. Now, e-cigarettes use e-liquid, which has significantly lower levels of harmful chemicals, to produce vapor without ash, and can be used with or without nicotine. And there are a variety of options to use. You can use e-cigars and pipes if you like the classic feel. You can use large or medium tank devices, or what is more prominent are rechargeable and disposable e-cigarettes. Multiple different groups have identified that vaping is 95% less harmful than smoking. So that's fantastic news. But vaping is not without inherent risks itself. You're still bringing things into your lungs which normally wouldn't be there. Your lungs are comprised of multiple different cells to help them function. You have a bunch of different epithelial cells which make up the alveolar sacs, and you have migrating immune cells which can help clear infections in the lung. In our body, we have lots of different immune cells, which are grouped into 2 major categories. You have adaptive response cells, which are slow acting but have very specific pathogen responses. And you have innate response cells, which are typically fast acting and have non-specific pathogen responses. The cells that we're going to focus on today are macrophages and neutrophils. Macrophages and neutrophils mediate immune responses by secreting proteins. Some of these proteins are pro-inflammatory cytokines and proteases. Neutrophils can release the protease neutrophil elastase, and macrophages can release matrix metalloproteases. These are actually really interesting molecules that have an important role in innate immune responses in the lungs, because proteases can help mediate antimicrobial activity, airway hydration, mucus clearance, cell signaling, and tissue turnover. And these are kept in check by protease inhibitors. And when there's a balance of protease inhibitors and proteases, it helps your lungs function appropriately. A disbalance of them can lead to pathogenesis, though. And what we know is that tobacco smokes can induce a disbalance of these. So if we know that tobacco smoke can cause a disbalance of protease and protease inhibitors, because tobacco smoke has nicotine in it and you can vape nicotine, what is the effect of vaping on this? And so this becomes a really important question. Because vaping is relatively new, we just don't know as much about it as we do smoke. So in the paper we're looking at today, it helps illustrate the effect that vaping has on our bodies, and in particular, it gives a more in-depth look at the chemicals in vapor and smoke. The paper that we're looking at today is by Ghosh et al. And is called Chronic E-Cigarette Use Increases Neutrophil Elastase and Matrix Metalloprotease Levels in the Lung. By investigating this topic, they found some really interesting results. They took 3 different groups of people who do not smoke, people who smoke, and people who vape, and compared immune cell populations in their lungs and respiratory function amongst all of them, and found that they were more or less similar. However, when they took a deeper look into the lung, they found that people who smoked or vaped had increased levels of proteases without a corresponding increase in protease inhibitors. So this indicates that vaping and smoking causes a disbalance of these levels in the lung. So this indicates that there is an increased net protease activity in the lung. And in their group of vapors, they found that in their saliva and mucus from the lung, their sputum, there was an increase in nicotine and its metabolites. So in knowing that there is an increase in proteases in the lung and there is nicotine present in the lung, what these scientists decided to do is look at specifically what about vaping can cause increased protease release. So they looked closer at neutrophils and macrophages and exposed them, the major component of e-liquids, which is propylene glycol, nicotine and propylene glycol with nicotine, and found that just the addition of nicotine, whether or not it was in propylene glycol, caused an increase in protease release from neutrophils and macrophages. And this was really interesting. We did not know that consuming nicotine by vaping caused this response. What the authors looked at further was specifically how this was happening. So they exposed macrophages and neutrophils to nicotine and found in doing so, it increased cytoplasmic calcium concentration, which in turn leads to the release of proteases. And this is some really interesting information that they found that significantly increases our knowledge about the effects of vaping. Particularly, it helps us understand just more about what happens when we vape. Particularly, this knowledge shows that vaping alters the protease inhibitor balance in our lungs and illustrates the present harms in vaping. Because even though vaping is 95% less harmful than smoking, it's still harmful. We shouldn't really be putting things into our lungs if we can avoid it, but it feels good. So it's kind of a trade-off that people choose. Fortunately, every scientific discovery is not a dead end. All scientific discoveries lead to more questions that can be asked. So I had a few of them when I was reviewing this paper. We know that when you vape, you don't just get nicotine and propylene glycol. There are a bunch of other chemicals that are in that vapor. So what I was curious about is what effect do those other chemicals have on neutrophils and macrophages? Also, smoking leads to disease all around the body. So does vaping also lead to disease all around the body? Does it affect not only cells in our lungs, but does it affect our cardiac muscles? Does it affect neurons? And a continuing question to be asked about vaping is, what are the long-term health impacts? Because this technology was only really popularized in the 2000s, we don't know about long-term vaping effects. That's an interesting area of research. So this is what I was thinking about when going through this paper. What I'm really interested in is what questions or thoughts you might have had when hearing about this paper. Also, what else are you interested in hearing about? Let me know about that in the comments below. Ultimately though, I hope you learned something, and more importantly, I hope that you had fun doing so. So if you did, give this video a like and subscribe for more in the future. With that, I will see you next time.